Hello my dear students, today I am going to explain a very important concept for exclusive in NEET and MAINS, that is ring expansion and ring contraction. In ring expansion, C4 is expanded to C5 ring, C5 is expanded to C6 ring. In ring contraction, C4 is contraction to C3 ring and C7 is contraction to C6 ring. Rarely C7 is converted to C3 ring only here. So when expansion and contraction is possible and how to recognize whether it is expansion or contraction. So here two tricks are possible to bring or to recognize expansion and contraction. So first rule, if positive charge, it is very important sir, if positive charge is on outside the ring, in this case expansion is possible. In this case expansion is possible. If positive charge is on along with ring, in this case contraction possible, right? In this case contraction is possible. If positive charge is on outside the ring, expansion possible. If positive charge is on along with the ring, contraction is possible. For example, here 4 ring, positive charge is outside the ring. Yes, here 4 ring, positive charge is outside the ring. That's why this ring expansion takes place here. So for example 1, 2, 3 and 4 expansion. That means between 1 and 2 carbon should be, covalent bond should be break between 1 and 2 carbon, right? So now this second carbon is going to be bond with this positive charge of the carbon. Now this first carbon loss of bond, that's why first carbon get positive charge. So right, the next step here, yes, this is the structure, right? So this is the first carbon, right? First carbon loss of bond, that's why here this is positive charge. Second carbon is going to be bond with this carbon, right? So 2, 3, 4 and 5. Total how many carbons here? 5 carbons are there. I mean C5 carbon is there. So write down like this structure. Yes, 5 member ring. First carbon, second carbon, third and fourth and fifth. So still first carbon is positive charge. That means carbocation. So now you have to observe here. This is C4 ring, right? C4 ring, but this is C5 ring. So now it is expansion takes place here, right? For example, next one more example. Right. So here also positive charge is outside the ring. That's why it is also undergo expansion, right? So 1, 2, 3, 4 and 5. So you have to observe here this is 5 member ring, right? So now in this case the covalent bond between 1 and 2 carbon, the covalent bond should be break here. Now this second carbon is immediately bond with the positive charge of this carbon and first carbon is loss of bond, that's why I get positive charge here. Right in the next step. So this is the structure. Next one, right here. So this is the first carbon, right? It is first carbon. First carbon loss of bond, that's why first carbon get here positive charge. Second carbon is bond with this carbon. Yes, this carbon. That's why it is 2, 3, 4, 5, 6 member ring, right? So write down the structure here, right? 1, 2, 3, 4, 5 and 6. Still first carbon is positive charge. So initially here this is C5 ring but after it is C6 ring. So it is expansion takes place. C5 to C6, C4 to C5. So these two are example for expansion. Next, contraction. You can observe here positive charge is along with carbon, right? Along with ring. Positive charge is along with ring. So now it is undergoes expansion or contraction. So it is 100% contraction because the positive charge is along with ring. So now here number 1, 2, 3 and 4. Right? 1, 2, 3 and 4. So in this case, the covalent bond should break between second carbon and third carbon, right? So I want break second and third carbon. So immediately what happened here, this third carbon is bond with first carbon, right? That is the next step here, right? It is first carbon, right? And it is fourth carbon and it is third carbon, right? So the third carbon is bond with first carbon. And this second carbon loss of bond, right? This second carbon is loss of bond. That's why the second carbon gets here positive charge, right? So structure. So actually this is the structure for that because 3-member ring is there, right? It is 1 and it is 4 and it is 3. Still first carbon having second carbon. This second carbon is positive charge. So initially it is C4 ring, but after it is C3 ring. So it is contraction takes place here, right? So C4 to C3. So next one more example here. So here 7-membered ring is there. Here positive charge. It is 1, 2, 3, 4, 5, 6 and 7. Yes or no? So here it is the positive charge is along with ring. That's why this ring should undergo only contraction but not expansion, right? So here 1 and 2. So 2 and 3. 2 and 3. I mean the covalent bond. It is covalent bond, right? This covalent bond is will break between second and third carbon. So immediately what happens? This third carbon is bond with the first carbon of positive charge, right? So right in the next step here, it is structure like this, right? It is 1. So it is first carbon. It is 7th carbon, 6th carbon, 5th carbon, and it is 4th carbon, and it is 3rd carbon. I told you already 3rd carbon is bond with first carbon. That's why first carbon, right? And this first carbon is second. First carbon is continue with second carbon, but second carbon loss of bond, right? This second carbon loss of bond. That's why second carbon gets here positive charge. Total, how many carbons in ring? 1, 2, 3, 4, 5, 6 rings. 6 carbons are there, right? So 6 carbon are there, right? This carbon having second carbon. Now it is positive charge only here, right? So initially it is C7, but after it is C6. Yes or no? First carbon having second carbon has positive charge. That's the second carbon. It is first carbon, it is second carbon, right? Remaining one, it is 7, it is 6, it is 5, it is 4, it is 3, right? So it is C7 ring contraction to C6 ring only here. Okay. So this is the way to understand expansion and contraction. Next example. Here positive charge is outside the ring. That's why it is expansion or contraction. It is expansion takes place. So it is 1, 2, 3, 4, 5 and 6. But in this case it is 5-membered ring, right? So here, but positive charge is on first carbon, right? Here between 2 and 3 carbon should be break here. Now in this case, this third carbon is going to be bond with the first carbon, right? The next step will be here, right? So here this is the first carbon, right? And the second carbon, in this case this second carbon, sixth carbon, fifth carbon, and fourth carbon. Third carbon is bond with first carbon, and first carbon having one methyl group, right? It is methyl group. If you seriously observe here, the second carbon, here second carbon is loss of bond. That second carbon get here positive charge. So rather than restriction, I think here one total how many carbons in ring? 6 carbon ring is there, right? Write in the 6 carbon like this, yes, write down. And it is the first one, second one, third, fourth, and as it is fifth, sixth, right? But here the first carbon having one methyl group, and it is second carbon, right? Here second carbon having positive charge, right? It is second carbon having positive charge here. Here what happened in this case here? This second carbon having carbon positive charge, this is called secondary carbocation. It is secondary carbocation, right? It is second carbocation. Then, I mean, one more step we need to understand here. Second carbocation. What is the main purpose of this expansion and contraction? To get stable product. To be understand how stable product will be formed, right? So here we know that for carbocation, tertiary carbocation is more stable than secondary carbocation, then primary carbocation, right? But is secondary carbocation. If you arrange this cyclic structure of carbocation, you will get tertiary carbocation of ring. How? Here one thing in this one step you have to do in this case. First carbon, right? This first carbon having one hydrogen is there, right? So in this case, this hydrogen is shifted towards this second carbon of carbocation, right? Here hydride shift is possible, not hydrogen. Hydride. Hydride means along with bond. That means H minus. So here 1,2 hydride shift. 1,2 hydride shift is possible. Yes, along with bond is shift towards this second carbon of positive charge. Now the positive charge is migrate here to here. So now write down like this. Yes, there is a sigma ring. So here having hydrogen, right? Because here along with bond we are shifted toward this second carbocation. So now here having one methyl group, but here loss of bond. That's why this carbon get positive charge. Yes or no? That's why now we can understand here this carbon is surrounded with carbon and also carbon. That's why this is called tertiary carbocation. So this type of situation is also possible in expansion. Yes or no? So that's why most of the students to pick this only correct option. No, it is not correct option. It is a correct option because for carbocation, secondary carbocation is more stable than secondary carbocation, then primary carbocation. So that's why you have to understand which is correct answer. Yes or no? So here tertiary carbocation is very stable than secondary carbocation. So this type of arrangement is possible. This type of arrangement is called 1,2 shift hydride. Here, if in case we have, there is a possibility to do shift hydride, phenyl and methyl. 3 are possible or 2 are possible. Which one will first to transfer or shift? It is order. So you have to know this order. So the order of shifting towards or transfer. First hydride is first of all hydride is shifting towards carbocation, then after phenyl, then after methyl. So this is the order of the shifting possible. Yes, sir, it is the order. First hydride, then after phenyl, then after methyl only here. Look at here. This is really very important question. It will help to understand what is the concept of ring expansion and ring contraction. And you have to pick up which is correct option here for this question. In before, you have to observe here what is the reagent. Aqueous AgNO is the reagent. So let me explain what happened in this case here, right? And which is the correct option. So here, in before, you have to understand here aqueous AgNO3, right? Aqueous AgNO3, that means along with water. So here AgNO3
to decomposes Ag plus NO3 minus. H2O, aqueous means water. H2O also decomposes H plus OH minus. So here what happened? Ag plus Br minus to eliminated as AgBr. Right? Here Ag plus Br minus to eliminate as AgBr. The next product will be here positive charge, right? Because Br is eliminated along with bond, that's why Br minus plus Ag plus 2 is eliminated as AgBr, right? And to get this product here. And here positive charge is outside the ring, that's why it is expansion or contraction. So it undergoes expansion. So now I want you number here 1, 2, 3, 4 and 5. So 1 and 2 carbon bond should break. The second carbon is going to be bond with this carbon. And first carbon loss of bond. That's why the first carbon get positive charge over here. Total 1, 2, 3, 4, 5, 6 member ring is there, right? 1, 2, 3, 4, 5 and finally this is 6 carbon only here. Right? Write down the structure here, write this. Right, 6 member. Yes. So you know what? It is first carbon, right? First carbon and fifth carbon, fourth, third and 2. Finally it is sixth carbon, right? Sixth carbon having one methyl group, because this is one methyl group. It is also one methyl group. And you have to observe here first carbon loss of bond. That's why it is positive charge. So here what are the left in this case? OH minus is left. This OH minus is going to be at this positive charge. No, it is not correct, because third option is already there. I told you already your arrangement is there, because this is secondary carbocation, that means 2 degree carbocation. If you arrange this one, you will get tertiary carbocation. I have already told you in the ring expansion concept, tertiary carbocation is more stable than secondary carbocation, then primary carbocation for stability order of carbocation. That's why here, in this case, here I told you already this mechanism. Here one hydrogen is there. Here this hydrogen is shift toward this positive charge of the carbon. Now here what happened? Here positive charge is migrates towards this carbon. Here hydrogen is there, right? Here already methyl is there and positive charge here. Right, because this hydride is shift. Here the hydride shift, right? I told you already hydride means H minus along with bond shift toward this carbon. That's why this carbon is loss of bond. That's why I get positive charge here, right? So here you have to observe here this carbon is tertiary carbocation, right? Because this carbon is surrounded with carbon, carbon and carbon. That's why this is the tertiary carbocation. I told you already. So tertiary carbocation is more stable. Right now, this OH minus ion is going to be attack this positive charge of the carbocation of tertiary carbocation. This is nucleophilic substitution reaction. So now finally, so what is the major product here? This is the major product here. Right? This is the major product. Look at here which is correct option here. So second one is the correct option. Right? So second one is correct option. This is the way to understand and to apply concept of ring expansion. Yes, next question. Which is correct option here? Same reagent, aqueous AgNO3. We know that already we discussed what is the reagent of AgNO3. Right? And you have to pick up which is correct option here. Look at here, this is already tertiary carbon, right? So AgNO3, already discussed here, AgNO3 decomposes Ag plus NO3 minus. Aqueous means water, so H plus OH minus. So this bond, I mean Ag plus Br minus is eliminated as AgBr, right? And here H plus NO3 minus HNO3, nitric acid is eliminated as in this case, remaining OH minus, right? OH minus, how these OH minus is attack this one. So the next product will be here. So here positive charge. right? Here positive charge is there. Yes or no? So now here positive charge, that's why ring expansion or contraction. Yes, it is expansion is possible here, right? That's why 1, 2, 3, 4 and 5. Right? Here bond should be break, and this second carbon is going to be bond with this carbon. Of course, you can take 6th carbon here. Right? I think total 6 member ring is there, right? So now these are the numbers. So 1, 5, 4, 3, 2, finally 6. But 6th carbon, 1 methyl, and similarly having 1 methyl, right? Because this is one of the methyl, it is also 1 methyl. First carbon loss of bond, that's why here first carbon get positive charge. Right? First carbon get positive charge. So I told you what is this 2 degree carbocation, that means secondary carbocation. So if you arrange, you will get tertiary carbocation. I told you already here, first transfer first, hydrogen ion is transfer, yes or no? First hydrogen ion is right to transfer, then after phenyl, then after alkyl. Alkyl means methyl, ethyl, like this over here. So here no hydrogen, here no phenyl, that's why only alkyl group is there. That's why between these two, anyone ready to transfer towards positive charge of the carbon. That's why here this one is ready towards positive charge. That's why here methyl transfer, right? So you will get here what are the main product here, right? Here methyl group is there, here methyl group, right? And here also one methyl group, and here positive charge is there. Yes or no? Here positive charge, because it is transferred along with bond toward this first carbon. That's why this carbon is loss of bond. That's why here positive charge. Look at here, this positive charge of the carbon, tertiary carbocation, right? And ring expansion. So before C5 ring, but it is C6 ring. This carbon surrounded with carbon, carbon and carbon. That's why this is 3 degree carbocation or tertiary carbocation. That's why it is most stable and 6 member ring expansion, right? Now this nucleophile OH minus is going to be attacked this tertiary carbocation to form finally the major product here. Here methyl group, here OH, and here CH3. Look at this one. So CH3, CH3, OH, OH, and CH3. So third option is the correct one here, right? Third option is the correct one here. So this is the way to understand what is the concept of ring expansion and contraction. My dear students, I hope you all of you understand about ring expansion and contraction concept. So please follow me, please subscribe my channel. Thank you.